Good morning, sir. Amar sir, कैसे हैं आप? Okay, so it's live. So I have to give a introduction about sir. Fine. So today, it's my pleasure and it's my privilege to have my ex-colleague and not ex-colleague. He's my still a colleague and he will remain my colleague, Professor Amar Singh ji from School of Computer Science and Engineering, Labri Professional University. He is here for delivering a talk on optimization because our theme of the uh, FTP is data science and data analytic tools for the researchers. Optimization is one of the things he will be speaking about. Before he starts, let me introduce to you all about his brief profile. Dr. Amar Singh is having 15 years of vast experience in academic and research. He's having approximately 100 plus research article indexed in SCIE, SCI, and Scopus Index Journal. More than 40 plus international conferences he has attended and he has presented his paper there as well. He's having more than 20 book chapters, and in addition to, he's having 15 plus patent which is being filed, and approximately 4 to 5 has been granted to him. He has worked on a very emerging technology, Life 5, which is going to revolutionize the things. We will be seeing it very soon. He has a patent on same, has been granted. 3 scholars have been awarded PhD under his guidance in the area of machine learning and artificial intelligence. And 7 scholars are presently pursuing a PhD under his guidance in LPU. In addition to LPU, he's also a co-supervisor in many other reputed organizations. And he's also editor of very reputed HCI index journals as well. Uh, Definitely, when I was there in LPU, I have learned a lot from him because the experiences he's having in the research is really very great. And I had requested him to please share his valuable time and valuable experiences what he's having. Can he can come over here and share with our participants and even with all of us, because we are all always in a learning stage. So Dr. Amar, I really once again welcome you on behalf of Department of Computer Science, Vadava Campus, University of Jammu, and my counterpart, Teaching Learning Center of Ramajan College, Delhi University. Dr. Arun Agarwal is with me. He's there from last 10, 15 days. We are engaged together. So we are happy again, and we once again welcome you, sir. Thank you very much for accepting our request. And sir will be delivering a talk on optimizations, because we have seen the research already. Some talks has been gone where we have seen the modeling, data modeling has been covered, but optimization was the part which was missing there. So that's why I had requested sir to come out with the optimization approach. So he will be talking about how optimizations can be done, because the research is not really taking a data and going for a model. What else is there? What novelty you bring? So he will be speaking about what novelty we can bring in our research for PhD or other things. So thank you very much, sir. Please go ahead. Now you're live on YouTube. More than 200 participants are watching you on the YouTube as well, sir. Thank you. Please go. Sir, you're not audible. You're not audible. I think you please check whether you are unmuted. Sir, you're not audible. आवाज नहीं आ रही सर, एक मिनट चेक करिए. You can please check again. Yes sir, not audible yet. Please try again, restart, or you can rejoin. Please rejoin. I think you can rejoin. If you find the trouble, you can rejoin. I feel there is some technical glitch at your answer. No issue. Yes, Amar sir, you have joined and you're connecting to audio. Let me see. Well, can we hear you? Yes, sir. Amar sir, can you hear me? I think I cannot hear you. Let me see with the Arun sir. Can Arun sir hear him? He can chat, put chat on window.
No, sir. No, sir. Amar sir is not audible.
Oh, ask to unmute. Okay, this is the thing. Okay, so yeah. So Amar sir can try again.
Hello.
Thank you, sir. We can hear you. Please go ahead.
Yeah. Thank you, sir. Thank you.
Please share your screen. You can share your screen. Thank you, sir. Go ahead.
Yes, sir. My screen is visible.
Screen is visible, and now we can hear you as well, sir. Please go ahead. No issues. Thank you.
Thank you, sir. So, the title of our session today is Machine Learning Model Development Using Big Bang Big Crunch Algorithm. So, now I shall start this session with the overview of machine learning, and we shall discuss in this session regarding the mathematical modeling of the machine learning models. Then we shall discuss that how we can optimize these models by using the optimization algorithms. So for the demonstration purpose, I shall discuss one very nice algorithm, that is Big Bang Big Crunch algorithm. So first I shall start with the introduction of machine learning. Then we shall discuss about the machine learning algorithms. Then after that we shall see their implementation in Python. After that we shall discuss the optimization part. So first of all, what is machine learning? In the simple words, we can say that machine learning is learning from examples. And what are the examples? Examples means our existing data. So if we are training our machine with the help of existing data, that is called as machine learning. Okay, how machine learning models works? Like this is one example of machine learning. As I told you that machine learning is learning from examples. Now, what are the examples here? These images are the examples. And this is the output of the examples like cats and dogs. So if we have to develop a software which has to recognize that whether the particular image belongs to cat or dog, so for that we can implement machine learning. And how we can train our system by using the machine learning? First of all, we shall give the images input data to the machine learning algorithm, and that machine learning algorithm will automatically write the code for us, that is called as model. So we shall give the inputs and outputs to the machine learning algorithm, and that algorithm can write the model for us. Algorithm could be any algorithm. It could be the clustering algorithm, it could be regression algorithm, or it could be the category of the classification algorithms. So in the machine learning, these are the examples. These images of cats and dogs are the examples, and these examples would be given to the machine learning algorithm. Now machine learning algorithm will write the model for us. That model can be imported in our software. We can import in the mobile apps, we can import it in the website, right? So that model will be imported in any software, right? The software can use this model, and if any new image comes, our model could be able to do the predictions for that image, whether that image belongs to cat or dog. Okay, so this is the machine learning. That's why we call machine learning as learning from examples. So we give the examples to the machine, and machine will write the code by using that examples. Now, why we prefer machine learning instead of the traditional programming approach? Here is the reason behind that, why we prefer the machine learning. If we look at the traditional programming approach, in the traditional programming approach, we do the programming with this way. We write the computer program by using the available data. After writing the program, we can get the output. Okay, and what is machine learning? In machine learning, we give the data and outputs to the machine learning algorithm, and that algorithm can automatically write the code for us. You can look the previous example. We are giving the data and output. What is data? Data is these data are these images, and outputs are name of these images. The data and output will be given to the machine learning algorithm, and that algorithm can write the code automatically for us. So automatically model will be created for us by using the machine learning algorithm. Okay, so it reduce the coding efforts of us. Automatically it is writing, like you can look this architecture, this architecture is automatically writing the code for us for image classification. Okay, so you just have to give the data and output to the machine learning algorithm can automatically write the code for us. So if you want to look at the examples, you can check, you can work on the Google teachable machine. From there you can get the idea that we are giving the inputs to the to our machine learning algorithm, and that algorithm is automatically writing the code for us. Now, machine learning algorithm, if we have to categorize the machine learning algorithm, machine learning algorithm is categorized into the three categories. We are having regression algorithms, we are having classification algorithms, and we are having clustering algorithms. In this session, I shall focus on the regression algorithms only. What is a regression? The purpose of regression is to predict the continuous values, and purpose of the classification is to predict the discrete values. The classification's purpose is to predict the classes. So we will not predict the continuous values by using the classification algorithms. So I shall focus on this algorithm, this category of the algorithm, that is regression. So by using regression, we can apply the regression algorithms to predict the continuous values. Like if we have to predict tomorrow's temperature, temperature is the continuous value. If we have to predict the sale of a company in next year, sale is the continuous value. So we can apply regression algorithms there. If we have to predict the credit score of a person, so credit score is the continuous value. So by looking the data set and by looking the output of the data set, you can identify that which category of the algorithm you will apply. If the data set is having continuous values, then you will apply their regression algorithms. If the data set is having classes like 0, 1, 2, like plant is having disease or not, uh, a patient is having diabetes or not, for that we can apply classification. And clustering we will apply there if we don't know about the output. Okay, so I shall focus on regression algorithms. Especially we shall discuss about linear and non-linear regression algorithms. So we have already discussed that the regression models are used to predict the continuous values. we are having different types of regressions: linear regression, non-linear regression, simple linear regression, multilinear regression. In the simple linear regression, if my data set is of linear nature and it is having only one input and one output, there I can apply simple linear regression. Now, in the simple linear regression, basically we predict a straight line on our observations. Like these blue dots are our observations, and we shall estimate a line on that observations. So what is linear regression here? The regression is this line. We have to estimate the line on the observations. Okay, so this is my regression model. This line is my regression model. And how I can estimate the line? To estimate the line, we are having this equation. The equation is y equal to b0 plus b1 multiplied by x. And here, if I am having simple linear regression, I am having this equation. If I am having multilinear regression, the equation will be b0 plus b1 multiplied by x plus b2 multiplied by x2 plus b3 multiplied by x3, and so on. Okay, so this is the equation of simple linear regression, and our purpose is to estimate a straight line on our observations. In the simple linear regression, this line is our prediction, and these blue dots are our actual values. Right, so we can do predictions with the help of this line, with the help of this straight line. The form of the linear regression is this equation. In this equation has been taken from the equation of the line from the mathematics. The equation is y equal to mx plus c. Now, if we have to plot the line on the observations, then we will use this equation. Now, in this equation, we are having two coefficients, b0 and b1, and x is our available data. So x would be given to us, but we have to compute b0 and b1. Right, now listen it very carefully. We have to compute b0 and b1. Now, how we can compute b0 and b1? For that, we are having different approaches that we shall see in the next slide. So b0 and b1 can be computed mathematically. We can compute it by using the search and optimization algorithms, and we can compute it by using fuzzy logic. So many approaches are there. So we shall discuss that approaches step by step. So first of all, the equation is b0 plus b1 multiplied by x1. We have to compute b0 and b1. So accuracy of our model will be dependent upon these two values, b0 and b1. I cannot put randomly b0 and b1. Okay, you can look here. If I put this here in this equation, b1 represents the orientation of the line, and b0 is the intercept on the y-axis. Okay, so by using b1, as I varies b1, the orientation of my line will change. Right, so most of the things are dependent upon b0 and b1. Especially I am fixing b0 is fixed. I am changing b1. When I change b1, the line orientation would change. Now, what would be the best line for me? To check that, which will be the best line for you, we are having a loss function. The loss function for simple linear regression is MSC. MSC is the loss function. So in this loss function, we shall measure the difference between the our prediction and the actual values. Okay, so here in the MSC, Fi is my prediction and Yi is my actual value. So what we will try in the simple linear regression, we shall try to minimize MSC. MSE is the loss function for simple linear regression, right? So we can take some values for B0 and B1 and check the MSE of the model. If MSE is not fine, again change the values of B0 and B1. Then check MSE. If it is fine, then otherwise again change. Okay, so we have to find the best values of B0 and B1. If the values are not good, then we will get the another orientation of the line. Okay, so we needed the best line on our data. Okay, now how we can compute B0 and B1? Right, now we are discussing that how we can find out the values of B0 and B1. We can find out the values of B0 and B1 mathematically. We can apply here search and optimization algorithms. We can develop regression models with the help of ANN, or we can apply fuzzy logic. So I shall focus on first three approaches. First, we shall see that how we can evolve, how we can compute a regression model with the help of mathematics. And what we have to compute? We have to compute the values of B0 and B1. In Python, you may work in Python and you may work on regression by using Python. In Python, I am having inbuilt package, that is sklearn. By using that package, you can fit the model. But what is happening at backend? If you have to modify that model, then how you can modify? Okay, so we shall discuss both approaches here, mathematical approaches, and we shall also discuss that how we can implement the regression model with the help of sklearn. So mathematical implementation first we see. So if you have to evolve, if you have to compute the values of B0 and B1, the values of B0 and B1, B0 and B1 are the coefficients, these are the parameters of regression model. So to compute the values of B0 and B1, we are having these two equations, covariance of X and Y divided by variance of X. And B0 can be computed with the help of mean of Y minus B1 multiplied by X mean. Okay, X is my input data, Y is my output data. Okay, so X is my input data and Y is my output data. Now, covariance we know very well from in higher schools. We have studied about these equations that variance can be calculated with this way. The equation is given here, and covariance equation is given here. X mean is the mean of the input values. Xi is the ith value of my input data. Y is my output data, and yi is the ith output of the ith observation. So intercept we can calculate by dividing covariance by variance. So n minus 1 and n minus 1 would be cancelled, then and the equation would be this one. Equation would be this one, right? This one would be equation, right? So this is the equation for B1. And what's the equation of B0? B0's the equation is Y mean minus B1 multiplied by X mean. So B1 and B0 we can compute by using these two mathematical equations. Okay, so now I have taken one example here. In this example, we have to predict the marks of Y subject. We are having two subjects here, X subject and Y subject. X is the statistic, X is mathematics and Y is statistics. So X is mathematics is my input and statistics is my output. So by looking the marks of mathematics, we have to predict the marks of statistics. So one input is here, one output. So I can apply simple linear regression here because one input is here. So I have to predict that if a student is having marks 80, 80 or 82, then how many marks he will get in statistics subject. If the student is having 80% marks in mathematics, then predict that how many marks he will get in the statistics. Or if the student get 90 marks in the mathematics, then how many marks he will get in the statistics. So this is my data set, and I have to apply simple linear regression here without using any method, any package of Python. So I am having input and output. X is given here, Y is given here. Y is my output, X is my input. So what I have to compute now? X is given. I have to compute B0 and B1. The mathematical equations are given here. So I have implemented these mathematical equations here. So X is given, Y is given. Now I have to compute X mean. This one. I computed the mean. Mean is 78 of X. Now compute the mean of Y. Mean of Y is 77. Now Xi minus X mean. X mean is 78. Okay. So 95 minus 878. That is 17. 85 minus 78. That is 7. 80 minus 78. 2. 70 minus 78 minus 8, and 60 minus 78, that is 18. So I have solved the part of this equation, first part of this equation. Now compute yi minus y mean with the same way. I computed the mean of y. So you have to write these instructions step by step in Python. I shall show the code also to you. So I have computed yi minus y mean. Okay. So y mean is 77. So yi is 85. 85 minus 77, that is 8. 95 minus 77, that is 18. So with this way, I have computed yi minus y mean. After that, I have to multiply these two terms. After multiplication, I will get these values. Compute the summation of it. So first upper part of this equation will get 470. Now in the lower part, compute xi minus x mean. So I have this is xi minus x mean, and scare this term. So 17 multiplied by 17, that is 289. 7 multiplied by 7, 49. So I got 730 here. Now this is the equation for B1. So I will divide 470 by 730. When I divide 470 by 730, I will get 0.644. So I computed B1 now. Now how I can compute B0? For B0, Y mean is given here. Y mean is 77 minus B1 is 0.644 multiplied by X mean is 78. So I will get 26.768. Now I got the values of B0 and B1. By using these values, I can do any prediction for my data set. Okay, so I evolved the regression model now. I know B1, I know B0, I know the X values also here. Now I want to do the prediction for 80. I want that if the student is having 80 marks, then how many marks it will get in the statistics. So what I will do, I will I have computed the B0 and B1. B0 is 26, B1 is 0.644. And what prediction I want to do? I want to do the prediction for 80. So I will multiply by 80. So if the student is having 80 marks in mathematics, he will get 78 marks in the statistics. Right. Now, by you can use this equation in any software. You can use it in your mobile app. You create a text box there, right? Input the value of the math and it will predict the value of the statistics. Okay, here's no need to import anything. Here's no need of any third party package. Many third party packages are available here on net to import the machine learning models. No, nothing is required. If you know about the parameters, just use that equations. Okay, so B0 and B1. Now I want to predict the marks of a student who is having marks 58. So what I will do? I know about B0. B0 is 26.768 plus B1 is 0.644 multiplied by 58. So what value you will get, that will be the prediction for the student who is having the marks in math, that is 58. So with this way, I can implement the regression models, simple linear regression models mathematically. Okay, so you just have to write like you are doing the creating a mobile app. In mobile app, you have to just implement this equation. You have to calculate the values of B0 and B1, and that's it. By using these values, you can do any prediction for the particular data set. So no need to integrate the data set also with the app. Nothing is required. You needed the two values only, B0 and B1, that you can compute by using the mathematical equations. So I shall show the mathematical implementation of this model by using the Python. So just 1 minute. For the implementation purpose, my this Jupyter notebook is visible to you. My browser
Visible,
tab.
visible.
Okay. For the implementation purpose, I have taken the data set. The data set is salary data set. First of all, I imported the data set in Google Colab. I am using Google Colab here. So I imported the data set here. After importing the data set, I imported the packages of pandas and numpy. Numpy is numerical Python. So for the numerical computations, we use numpy, and pandas is used for the data analysis purpose. Now, after importing these packages, I imported my data set here, and data set I imported by using read_csv command. Now, this is my data set. Here, experience is my input and salary is my output. So I want to predict the salary of a person with the help of experience. Okay, so I have imported my data set here. Now I want to implement simple linear regression without using any package of Python. So X is having experience and Y is having the output of my data set. So first of all, I shall compute mean of X. Same, I have to implement the same equations. Then compute Y, mean of Y. Then X minus mean of X. Then Y minus mean of Y. So I implemented the simple mathematical instructions here. So step by step, I am solving the equation. Now X minus Y. So what is X? Y is Y minus Y mean, and X is Xi minus X mean. So after that, I computed the sum. Then after computing the sum, I subtracted the terms. I am following the same equation, right? So after following the equation, you can look here. I computed the value of B1. B1 value has been computed with mathematically. Then I want to compute the value of B0. The same equation I implemented here. Y mean minus B1 multiplied by X mean. So I computed the value of B0. After computing the value of B0, I plotted the regression line. You can look here. This regression line I computed mathematically. Right. Now I want to validate it, whether it is predicting fine or not. Graphically, it's looking fine. Now I want to predict that if a person is having 7-year experience, what salary he will get. So implement the regression algorithm here. B1 multiplied by 7 plus B0. So if a person is having 7-year experience, he will get 20,000 salary. Okay. Now if I have to write here, let me check it. If a person is having 5-year experience, then what salary it will get? Let me check whether Google Colab is working right now on my system. So it is executing. Okay, just 1 minute. Let me import the package first. So I will import the files from Google. Then I will import my data set. And in the data set, I will take one data set. The data set is salary data set. I imported the data set. After importing the data set, I will import the uh, data set in Google Colab. So I shall execute my mathematical equations. So I computed the values of B1 and B0. Now, if a person is having 5-year experience, he will get 15,000 salary, 15,892 salary. Now, if I want to implement it with the help of sklearn, with sklearn, he has no need to write any mathematical equation. You have to import linear regression from sklearn. After importing the linear regression, you will create the instance of linear regression, that is LM. Then I am having two columns, experience and salary. So X is my input and Y is my output. Now, rather than typing the mathematical equation, I shall just type the command, that is lm.fit. So with the help of lm.fit, my model will be created automatically. So with just one command, I have computed my model. I have evolved my model. Okay. So if you want to check the value of intercept, that is B0, that is 3291, and B1, that is 2520. Same values we have computed with the mathematically, with the help of mathematical equations. You can look here. B1 is 2520 and B0 is 3291. And same values are computed with the help of sklearn also. Right. So what's the purpose of this discussion? The purpose is that if you want to optimize your model, then you have to work on the values of B0 and B1. You should know that what is B0 and what is B1 and how it can be calculated, how it can be computed mathematically. And what is multilinear regression? In the multilinear regression, instead of one input, we are having more than one inputs. The equation of multilinear regression is B0 plus B1 multiplied by X1 plus B2 multiplied by X2 plus B3 multiplied by X3, and so on. Here B0 is bias term, and B1, B2, B3, B4 are the coefficients of the regression model. Now I'm skipping the implementation of multilinear regression due to the shortage of time. In the multilinear regression, we are having multiple inputs and one output. Right. So like here, we are having some inputs and one output is here, that is y hat, and b0 is bias. If you observe this diagram carefully, then you will observe that we are using one neuron here. It is looking like the equation of artificial neural network, right? So this is the regression model which is using one neuron. This is the regression model which is using one neuron here. And if we are using one neuron in the artificial neural network, then what will happen? If we are using one neuron, means perceptron model we are using, with that perceptron model, we cannot solve non-linear problems. Right. That's why it is called as linear regression, because I am using one neuron only here. So this equation is same as the equation of artificial neural network. That is B0 plus W1 multiplied by X1 plus B2 multiplied by X2 and so on. So this is the equation of the one neuron. This is the summation equation, right? So with the help of one neuron, I can solve non-linear problems I cannot solve that which are having I cannot solve that data sets which are non-linear nature. Like just 1 minute. Okay. So if my data set is of non-linear nature, I cannot use their multilinear regression, because multilinear regression will find out the straight line here, right? By using the non-linear regression, I have to find out the curved line. So multilinear regression is not suitable for us if my data set is of non-linear nature, right? If my data set is very complex, I cannot apply multilinear regression there. If my data set is complex, then instead of this one neuron, I have to use multiple neurons here, right? So I needed the non-linear architecture here. So two solutions are here. One solution is that we can work on our data set. We can apply polynomial regression here. Okay. And another solution is that, because if my data set size is very high, it is not possible to apply polynomial regression there. If dimensionality is already high, then it is not possible to apply polynomial regression there. So another solution is that we can use artificial neural networks here. Instead of by using this multilinear regression, I can use artificial neural network. So instead of using one neuron, I can use multiple neurons. So artificial neural network is the solution for this problem. But in the artificial neural network, it is having a challenging issue. The issue is that how many neurons we shall keep in the artificial neural network. Okay, we can keep the artificial neural network with this way, or we have to keep it with this way, or we have to keep it with this way. So we have to do the manual tuning of the architecture, which is very time consuming, right? So if I have to decide the architecture, it will take so much time. If my data set is complex, I am using deep neural networks where we are having multiple layers, then how I can decide the architecture of ANN? It would be very difficult for us, right? Thus, here's the need of any approach which can automate this process, which can tell to us that what could be the best architecture for the machine learning model. If my architecture is best, the performance will also be good. So for this automation, for this architecture automation, I have used one approach. The approach is Big Bang, Big Crunch approach. This approach is automating the architecture, it is automating the architecture designing of the artificial neural network. Automatically it can evolve the architecture for us, right? So in our proposal, I am optimizing the weights also. I am evolving the weights also by using the Big Bang Big Crunch approach, and I am also evolving the architecture of ANN. Okay, so that any person who is not having the knowledge of machine learning, he should be able to train to evolve the machine learning model. Okay, in our proposed approach, we taken the existing data set. That data set is given to the Big Bang Big Crunch approach. So I am discussing here Big Bang Big Crunch approach. You can apply any search and optimization approach. You can apply genetic algorithm. You can apply PSO. Any algorithm you can apply. But I observe that BBBC is giving more good performance as compared to the existing approaches. So I given the data set to the BBBC approach, and BBBC approach will evolve the machine learning model for us, right? So it will evolve the optimum architecture of the neural network for us. So first of all, I want to give the quick introduction to you regarding Big Bang Big Crunch. Then I shall show the architecture to you. So Big Bang Big Crunch is the search and optimization algorithm. This algorithm is based upon the evolution of universe. Big Bang Big Crunch algorithm works in two phases: Big Bang phase and Big Crunch phase. Okay, so in the Big Bang phase, you can look here. In the Big Bang phase, from one particle, multiple particles are created, and in Big Crunch phase, multiple created particles are converged to one particle. Okay, so if I have to computerize this algorithm, what I have to do, I have to create the random population with the help of Big Bang phase, right? After creating the random population, I have to select the best solution from that population. That is called as Big Crunch phase. So this algorithm works in two phases: Big Bang phase and Big Crunch phase. In the Big Bang phase, initially random population is created. Okay, so initially we will create the random population with the help of Big Bang phase. Like you want to evolve the architecture of the neural network, you will create the population of the hidden layers and neurons in the hidden layer. Okay, you create the random population of the neurons in each layer. Okay, so in the Big Bang phase, we shall evolve the initial population randomly. In the Big Crunch phase, we shall compute the fitness of each individual in the population and select best individual from that population. So selection of the best individual from the population is called as Big Crunch phase. Right. In our population, we are having many candidate solutions. So selection of best candidate solution is called as Big Crunch phase. So best solution is called as elite. After selection of elite, we shall generate a population around the elite. Okay, when the new population is generated around the elite, again Big Bang phase would be started. After generating the population around the elite, we shall again select the elite. It means we will enter in the Big Crunch phase, again generate the population around the elite, that is Big Bang phase. Okay, so this is the Big Bang and Big Crunch phase. Okay, so this algorithm will switch in between Big Bang phase and Big Crunch phase. This is the algorithm for Big Bang Big Crunch based algorithm is here. So in this algorithm, first of all, we will generate a random set of the candidate solutions we shall generate a population of some candidate solutions. After that, this is called as Big Bang phase. After that, we shall compute the fitness of each candidate solution. After computing the fitness, we shall sort the population according to the fitness and select the best candidate solution from there. Best candidate solution is called as elite. After selecting the best candidate solution, we shall generate the new population around the best candidate solution. Again, we shall enter into the Big Bang phase. So with this way, the algorithm will switch in between Big Bang and Big Crunch phases. So this algorithm I have written in the steps. Step 1 is generate initial population randomly. Okay. So if you want to generate the number of neurons, you can say that in first layer I am having first 5 neuron, in second layer I am having 7 neuron. So with this way you will generate the candidate solutions for the particular population. So initially you will generate the population randomly. After that you will compute the fitness of the candidate solutions. After computing the fitness, select the best fit candidate solution. After selecting the best candidate solution, generate the new population around the uh, uh, best candidate solution. Here XC is the best candidate solution. How the new population will be generated? By adding or subtracting a small random number in it. We shall calculate the new candidate solutions around the elite with this way, right? So this process will continue until we get the desired solution. Here's one example of Big Bang Big Crunch algorithm. In this example, I have created a program to compute the largest sum of 3 digits. We know very well for the 3 digits, the largest sum will be 27. So every digit would be 9. But we want to find out that digits by using Big Bang Big Crunch, which will produce the largest sum. So I have written the program in MATLAB here. So I have created the population here. And first of all, I generated the initial population, and the boundaries of this population is that the lower number would be 0 and higher number would be 9. Okay. And I generated the population here that is called as Big Bang phase. After that, Big Crunch phase starts. In Big Crunch phase in the Big Crunch phase, we shall compute the fitness of each candidate solution. Okay. And we shall select the elite here. Elite means best candidate solution we shall select here. After selecting the elite, we shall generate the array of the random numbers. After generating the arrays of random numbers, I shall add my elite in the particular array. This array of random number is by change matrix. So I will generate an array of random numbers between -1 to 1. Okay. So one array would be created and elite will be added in that array, right? So I have generated the new population around the elite here. Step-by-step execution of Big Bang Big Crunch algorithm is given here. From here you can get better idea. So you can get the idea that what is candidate solution here and what is Big Bang phase and what is Big Crunch phase. So initially in the Big Bang phase, we shall generate the population of candidate solutions randomly. And what's our objective? To find out the 3-digit quantity, which is giving us the largest sum. And the 3 digits, all the three digits should be between 0 to 9. So I generated a population randomly here. In this population, I am having 3 candidate solutions. Okay, I have generated 3 numbers 9, 4, 5, 7, 5, 5, 1, 5, 3. So this 9, 4, 5, 755 and 153. These are my candidate solutions. Okay, now evaluate the fitness of this population. The fitness of this, the first candidate solution is 9 plus 4, 13, 13 plus 5, 18. Right, fitness is given here. The fitness of second population is 7 plus 5, 12, 12 plus 5, 17. And fitness of the third population is 1 plus 5, 6, 6 plus 3, 9. So I evaluated the fitness of these three candidate solutions. Now, which candidate solution is best fit here? Which candidate solution is elite here? It is clear that 945 is best, right? So I will select the best candidate solution from here. Now, best candidate solution is 945. Okay. So step one was big bang phase. Step two is big crunch phase. So in the big crunch phase, I selected the best candidate solution from here. Now, in the third step, I shall generate a population around my elite. What is elite here? Elite is 945. This is my elite. Okay, I shall generate a population around this elite. Okay, how I can generate the population around this elite? By adding or subtracting a small random number in the elite. I will again regenerate the population. So in the for the addition and subtraction, I created the change matrix here. 1 will be added in 9. So if I add 1 in the 9, it will give 10. But my upper bound is 9. So I will keep it as 9. So 1 will be added in 4. New candidate solution will be 5. 5 will be added in 1. New candidate solution is 6. So new candidate solution has been created around 945. And again, 1 will be subtracted from 9. So it will give 8. 1 will be added in 4. It will give 5. 1 will be added in 5. It will give 6. So I am creating new population here around the elite. After creating the new population, again, I will evaluate the fitness of my population. What's the fitness of the first candidate solution? The fitness of the first candidate solution is 9 plus 5, 14, 14 plus 6, 20. So fitness of first candidate solution is 20. And second candidate solution, 8 plus 5, 13, 13 plus 6, 19. And fitness of the third candidate solution is also 19. Now, who is elite here? Elite will be the first population, this one, right? So elite will be 956. That is 14 plus 6, 20. Again, this is my elite. Now, again, I have to generate the population around this elite. So this process will continue until we reach to the termination criteria. Termination criteria is iterations. How many iterations you are giving to the to your program. Okay, so I have also executed this algorithm. This is the algorithm. So, and I have executed this algorithm for 50 iterations. So I executed my program, and you can look here. It is finding the digits who is giving largest sum to me. It is able to find the numbers 999. Right. So with this way, I can find the solutions within the given search space. Right. I found the digits for the largest sum. Now you can find out the neurons within the given particular layer. Right. You can generate the population with this way. Like in the first layer, I can have 5 neurons. In the second layer, I can have 7 neurons. Right. Like here the population is given. You can say that in first layer I can have 9 neurons. In the second layer I can have 3 neurons. In the third layer, I can have 2 neurons. Then evaluate the fitness of each candidate solution, right? And which candidate solution is fit, generate the population around that candidate solution. Okay, so with this way, you can implement Big Bang, Big Crunch algorithm. Now, this algorithm we have implemented for the machine learning model development. This is the complete algorithm to automate the machine learning model development process. In this algorithm, first of all, you will start with the single neuron architecture. Then you can evolve the weights of your architecture by using Big Bang, Big Crunch algorithm and calculate the fitness of that architecture. If the fitness of that architecture is fine, then you can stop there. If fitness is not fine, then you will add one hidden layer in your architecture. Right. After adding one hidden layer, you will tune up the neurons within that layer. You can execute the number of iterations there and tune the hidden neurons in that particular hidden layer. After tuning the neurons, if the solution is acceptable, then it's fine. Otherwise, again add one more hidden layer in the neural network. After adding the hidden layer, again tune the neurons and the new neurons in each layer by using the Big Bang Big Crunch algorithm. Okay, after tuning, after the particular iterations, if the solution is acceptable, then it's fine. Otherwise, add one more hidden layer there. So this architecture evolving process will continue until you reach to the desired solution. Okay, so this is the proposal. With this way, you can evolve the number of neurons in the particular architecture, and you can evolve weights also, right? You can evolve weights also. So you can develop the complete machine learning model architecture with this way. Because this this training process will take so much time. That's why I have taken the screenshots of my execution. I shall show the screenshots only because the training will take near about 30 to 40 minutes. So that's why I have taken the screenshots of my execution. When I trained my system on the given data set, the data set is battery charging data set, rapid battery charging system we have created with the help of Big Bang Big Crunch algorithm. In this algorithm, after the training my model, I have evolved the architecture of my ANN. In this architecture, I found that I needed 2 layers for my data set, right? In first layer, I needed 6 neurons, and in the second layer, I needed 4 neurons. So this architecture is evolved by using the Big Bang Big Crunch algorithm. Okay, so number of input variables was there 2, and number of candidate solutions I taken 10. When I executed my program, so I observed here it has optimized the architecture within the 20 iterations only. And here's one switch at the 92th iteration. Okay, so it is optimizing the architecture iteration by iterations. This model was evolved. This model was evolved by my program, right? In this program, in the first layer, it evolved that I needed 6 neurons. In the second layer, I needed 4 neurons. So by using this architecture, I got this MSC. Okay, and this is the data. This is here. It is shown that the difference between my computed output and desired output. Okay, so computed output is very near to the desired. So I can show in MATLAB also to you. this architecture was evolved by using the given algorithm. So I have evolved here weights, and I have evolved the architecture, and my architecture is also automatically writing the code also for my particular problem. Okay, so I want to conclude my presentation now. So in this session, we have discussed that the regression models can be evolved mathematically. Linear regression models can be evolved mathematically. But if my data set is of non-linear nature, then we needed the non-linear regression models. For non-linear regression models, we are having polynomial regression, but the polynomial regression uh, is having the drawback if my data set is very complex, right? It is already having higher dimensionality, then we cannot increase its more dimensionality, because polynomial regression will work on the dimensionality of the data set, right? So we cannot increase the complexity of our data set. If my data set is very complex, we will not get the better outputs. So polynomial regression is not solution for the non-linear data. So the solution is artificial neural networks. Now, artificial neural network is having the drawback that what could be the architecture of the ANN? It is very time consuming process, right? So if we are having the complex problems, for complex problems, manually we cannot tune up our neural network. Okay, we needed any process which can automate the architecture development process. For the automation purpose, we can use Big Bang Big Crunch algorithm. Right. I used Big Bang Big Crunch algorithm. You can use any search and optimization algorithm. Okay. So by using this algorithm, you can optimize the architecture of one artificial neural network. Okay. So we proposed one Big Bang Big Crunch algorithm to automate the design of artificial neural network models. So now if you are having any question, then you can ask.
Great, sir. The fantastic thing is to started on time, and you also finished well in time, sir. Definitely, you have presented two things here, two different tools, the Python as well as the MATLAB. One of the important aspect in your talk, which I feel, sir, you really said wonderfully. The very important thing is all the time what we have seen, the people are using ready-made plugins, the like the toolkits, they are using NumPy or Pandas or skitlearn for machine learning and all that model. What happened exactly when even I am on the research panel of so many researchers, and even you are, what we have faced when we asked to a researcher that you used machine learning, okay, decision tree, how decision tree work, or how random forest works, how regression works, they do not know anything at the background, because they just reply, sir, I have used this library from the Python and this library in the MATLAB. You explain the things mathematically, like regressions and how it works and what is the mathematics behind that. That's really a wonderful, sir. And this is really the requirement, because today we are talking about explainable AI. So this is what explainable AI, that how your model is working like this, why it is behaving like this, what is the mathematics. You really explained it very properly, sir. I have a one question, sir. uh, can we also optimize the number of neurons? Okay, the number of layers, we can hidden layers we can optimize. Can we also optimize the number of neurons, sir?
Yeah, definitely, sir. We can create the population of neurons like I shown here in my slide. You can look here. I created the population here,
Okay.
right? So if I'm having 3 hidden layers, I can say that in first hidden layer, I needed 9 neurons. In second hidden layer, I needed 5. In third hidden layer, I needed 6. So with this way, I can create a population of neurons, right?
Okay.
Then I can evaluate the fitness. After evaluating the fitness, I will get elite.
Okay.
Then after getting the elite, I will generate the population again around this elite. So with
Okay.
this way, we can optimize the number of neurons in one artificial neural network.
That's great, sir.
Like you may see in the convolution neural networks that many researchers come with one architecture, right?
Right,
They are
right.
randomly selecting the architecture from there,
Okay.
right? So we needed any process here which can automate and which can give the best architecture to us rather than manually tuning of that one,
Very
right?
nice. Very, very nice.
And
So this is
second thing, we have discussed the mathematically. Many researchers, what they do, they use the third party packages to import the model. There's no need to use the third party packages. If you know about your parameters, just use that parameters in your software. That's
this is very important thing you told, and you have also shared with us that we need not to use the we must avoid as much as possible these plugins or these
right, sir.
libraries,
Because
because
if we are creating commercial products, for commercial products, we cannot use third party packages.
third party, you're right, sir, right, sir.
So
And even what is a black box again behind the working of any model, we do not know. So this is the new era, you're right, sir. So definitely this is wonderful, sir. And since this is live and people are not allowed to ask the question on Zoom, because we have a limited people here on the Zoom restaurant live, but I'm getting a good response on YouTube streaming, which I'm watching here. So that is very great, very nice, sir. This is a wonderful presentation. You really have covered a very evolving area of the research, that is optimizations. So this is really very nice, and our researchers and the faculty members are the the participants who are about to join a research. This will be a nice talk and nice experience they will be getting from your talk, sir. So once again, sir, once again, my warm regards, my thanks to you for joining and accepting our request. And this is really wonderful, sir. And in future also we will be associated with you for some future research collaboration and other things, although I'm already engaged in research in collaboration with you, because I'm learning a lot. So this is definitely very nice, sir. So once again, on behalf of Department of Computer Science, University of Jammu, and Teaching Learning Center of Ramajan College, Delhi University, I extend my warm regards. My thanks to you for sparing your valuable time with us and sharing your experiences in the area of research, especially in the area of optimizations, with all of us on this platform. Thank you, sir. Thank you. Thank you very much.
thank you, sir. Thank you very much for providing me the opportunity. And thank you, participants. If you want to communicate with me regarding any topic of machine learning, you can communicate with me. You can get my email ID from the internet also. It is available on Google Scholar. So you can get from there also. And Ashok sir, you can share
Yes,
my email ID with the student, with the
yes,
participants. Right.
fine, sir. Fine,
Ji,
sir.
ji, ji, ji. Thank you, sir. Thank
Thank
you
you.
very
Thank
much,
you,
sir.
sir. Thank you, sir.
Thank you.
Okay.